Hi, my name is Parchami from Max Planck Institute for Informatics, and in this video I would like to present our work Good Teachers Explain Explanation Enhanced Knowledge Distillation. This work would not have been possible without my collaborators Moritz, Sukut, and Bernd. Knowledge distillation has proven as an effective model compression approach for distilling large teacher models. The original idea proposes to train a student to match teacher's logic distribution over the distillation data. A recent work demonstrated that this simple setup can be sufficient for the student to match teacher's accuracy. But would this always indicate a successful distillation? Well, a recent work looked beyond accuracy and measured the agreement between the two models. That is, how often do the teacher and student give same predictions for the same input. The authors discovered that despite matching accuracy, the agreement can be significantly low. Here we demonstrate this with a simple figure where both models are 66% accurate, yet they only agree on 33% of the samples. This observation indicates that there can be a disparity between the two functions. In this work, we focus on faithful knowledge distillation. Faithful KD looks beyond accuracy and considers teacher and student, which are functionally similar. What would this imply? First, as mentioned by prior work, the student should not only have high accuracy but also high agreement with his teacher. This should also be considered in limited data settings, as often the complete data set that was used for training the teacher may not be available for the distillation. Secondly, even if the two models give similar predictions, a faithful distillation would ensure that they base their decisions on the same input features. If one has a teacher that focuses on correct class-specific input features and thereby is robust to distribution shift, as one can see in the green column, one would of course want the same to appear on the student. Lastly, given that the current large models are required to have certain degree of interpretability, a faithful distillation would also ensure that the student is as interpretable as its teacher. In this work, we consider these three desiderata and evaluate each separately. In addition to the evaluation, we also explore whether the existing model explanations can be used to bring the teacher and student closer. Specifically, prior work has shown that one can steer the model's training using model explanations by using, for example here, bounding box annotations. We do this by simply adding an explanation matching on top of logic distillation. We simply take the explanations of the teacher's predicted class on both models and match them using cosine similarity. This does not require any label information and does not introduce any new parameters. It is also model agnostic, as one can simply utilize the existing explanation methods without the need to explicitly refer to the architecture of the teacher and student. As for our explanation methods, we explore both post hoc explanation method, here GradCam, and also model inherent because explanations. For more info on these methods, please refer to their original papers. Now let's go back to our desiderata and see the gains we get by matching explanations. On the right, you see three distillation setups on ImageNet with different teachers. We observe consistent accuracy and agreement gains by adding explanation matching on top of logic-based distillation. We particularly see larger gains on limited data settings. We also explored distillation on unrelated images, that is, using images of another dataset for distilling the teacher. We see that even in this setting, the explanation provides useful signal for the student. For the second desideratum, we consider a binary classification setting between water bird and land bird, whether at training time the bird and background type are spuriously correlated, while at test time there exists a distribution shift. We see that our teacher is robust to such distribution shift by focusing on the bird and not the background. With logic-based KD, we indeed observe that the student may deviate from its teacher, and this in turn results in lower OOD performance. By adding the explanation matching on top of logic distillation, we see that we are able to maintain the reasoning of the teacher, and the student keeps focusing on the bird and not the background, and therefore is more OOD robust. This is of course quantitatively evaluated in the paper. For the third desideratum, maintaining interpretability, we consider two teacher models with desirable explanations. Specifically, one has explanations with high EPG score and the other with high IOU score. We observe a significantly more faithful distillation when our loss is used. We also explore distilling a teacher that has a higher degree of interpretability because of its architecture. Specifically, it has been shown that the interpretability of VIT can benefit from CNN tokenizers. Here, we instead explore attaining such interpretability through distillation of a CNN to VIT. We see that VIT students become significantly more interpretable with our loss. We also get consistent accuracy and agreement gains on ImageNet. In the paper, we also measure the shift equivariance of explanations as a property of the CNN and measure whether it's distilled to the VIT. Lastly, we also explore extending our loss to fixed distillation settings, where instead of querying the teacher for logits and explanations for every batch, we pre-compute the logits and explanations, and during the distillation apply the same augmentation on images to our stored explanations. For further details, please refer to the paper. Thank you.